All right. Good morning, folks. I wanted to back off of yesterday's lesson a bit. Yesterday we talked about some weld joints and some preparations and stuff like that, and angle of attack with the rod. Today we're going to put that into practice. So we're going to run into a shop here. I'm going to set up a couple pieces of steel. We're going to tack those together, and then we're going to do a bit of welding on them. But we're going to talk about how that joint is going to be constructed. So we're just going to make a T-joint with 2 pieces of steel this morning, probably 1/4 inch steel. And what we're going to do is we're going to clean up that steel beforehand. As we work with the steel, as the steel ages, gets cut and handled by the saw, there could be cutting fluid on it. It forms a bit of a layer of scale and crud on top of the steel. And that's never really good for welding, so we want to clean that off. So we're going to pop in the shop, we're going to grab a couple pieces of steel. We're going to clean them up nice, we're going to tack them up, and then we're going to grab some 718 welding rods, and we're going to put some welds on there. We're just going to do a horizontal fillet today, guys. So that's a 2F. It'll be the same position I demonstrated on the board yesterday, just so it's going to be more clear to you guys. I'm not going to do the extreme angle stuff. I'm going to put mine in at about a 45-degree angle, and the way it should be. But I'm going to build a 3-pass weld. And we're going to talk about how to stack the beads to create these welds, and the best way to do so in order to become successful at completing these welds. So we're going to swap these out firstly, and we're going to head into the shop. You guys for a walk with me this morning. So we're going to use a couple of the drawings from yesterday to help with today's lesson. So we're gonna roll this right over here. Boom. Let's see what we got. I'm thinking this weld right here is what we're going to draw on. So see that there. What we're going to do today is we're going to put a 3-pass weld on. Multi-pass, whatever you want to call it. Basically, what we want to do is we want to get our first pass in there, and we want that to come in at that 45-degree angle to be equal legs, and that's going to be right here. So that's pass 1 on a weld joint. Our second pass, I'm going to do in a different color. I'm going to do it in blue. Second pass, I want to basically push up against this one. I want to come in and I want to weld or aim my rod right at the toe of this weld here. So that blue dot is right where I want to weld. That's called the toe. That's where the edge of the weld basically connects to the base metal here. And that's where I'm going to point my rod for this next weld. And what that's going to do is going to flow and push this next weld kind of up like this. So we're going to have that weld basically backing off of that weld, and it's going to create that nice shelf there. You're almost going to entirely cover up that first weld with your second weld, but that's completely fine. The whole goal here is to create a nice shelf and space for our third weld. What I do recommend with these ones here is if we're working with thinner material or we're welding fairly hot as far as amperage goes. If this is thinner plate, you can actually overheat this. You can put a lot of heat in this. And what's going to happen is when you try and put that third pass in, we're going to end up with an undercut. And that's not a good thing. So in here, you guys are completely free to go cool your steel down. You dunk it in those cooling bins. And that's going to help you control your heat input. Another thing you could do is you could also turn your amperage down a few amps as the temperature of the plate increases. There's a bunch of different ways to approach the problem. I'm just basically looking to see that you guys can create a weld with no undercut. Undercut is a weld defect, and we obviously don't want that in our weld. But our third and final pass here, I'm going to put back on in red. And we're going to point it right here. So at the opposite toe of where we placed the last weld. So we placed the last weld at the lower toe to give us that nice shelf. So here, we're going to point right at the upper toe. We have this nice shelf here to work with, and that should help us create a nice, good-looking weld right there. Kind of in 3 passes. That's how it's broken down. It's going to take a little bit to figure out how to shape these, how you like to shape them, how to get your overlap, how to stay steady. But overall, what we're looking for here are equal legs. So this distance, X, being the same as this distance, X, and a pretty even kind of 45-degree angle to the weld. That's what we're looking for overall. So hopefully that breaks down that little bit. What I'm going to do is I'm going to grab a couple pieces of steel. We're going to head over to a booth. We're going to clean that steel up beforehand. We're going to set up a welder, and we're going to tack these together. I'll show you what those tacks are. And then we're going to create a 3-pass weld on one of these pieces. Just going to show you guys what it should look like. Consistency, travel speed, even straight lines. Hopefully I can model all of that for you this morning. So I'm going to grab the steel, and then we're going to head over to the buffer, and we're going to start cleaning that up. We've got a couple pieces here, 6 inches by 1/4 by 1 1/2 inches. This is what I like to work with in the shop here. So we're going to clean these up. So as you can see, we've got some junk on them. They don't have to be absolutely perfect, but it is good practice to get into to clean up steel before you weld it. You never know what's on it. It could be junk, grime, oil, grease, some sort of chemical, brake clean, anything like that, especially brake clean if it's chlorinated. Going to react to UV light. And basically what you end up with is chlorine gas. And chlorine gas is not something that you want to breathe in. In fact, it is a weapon of war. Chlorine gas was used during the wars to help neutralize opponents. Not a very good way of doing things. Pretty inhumane, pretty gross. War in general is not good, but yeah, gas especially. So we're not going to make any gas in here. That's why actually in the shop, I don't use any chlorinated brake clean at all. I use the non-chlorinated. That way, if we are cleaning parts to weld on them, we don't take that risk. So another little measure I take to help keep you guys safe in this shop. Okay, so with this, face shield, wear it. Lots of little needles on here flying at high RPM. You don't want them in the face. So we're going to put one of these on this morning. All right, so I'm gonna take you guys for a walk. We're gonna go set up in a booth over here. We're working with these welders here in these booths, and they've been working pretty well. So what I'm gonna do is I'm gonna set some stuff up. We'll do some tacking. I'll kind of keep you guys involved in the process, and we'll see how that goes. Hopefully we can see everything fairly well in here. Yeah, this isn't bad. Okay, good. So firstly, I like to create a nice workspace. So I move things that might be in my way, out of my way, do a little bit of cleanup. Got some tools laying around in here. So let's get ourselves ready to go. Since we are using the shielded metal arc welding process right here, we're gonna need a ground clamp and an electrode holder. So let's get those connected. Got our ground clamp here. So let's connect that to the back of the table. As long as it's connected to the table and can make a nice electrical contact with your workpiece, that's going to be completely fine. It does not have to be connected directly to your workpiece. So we got our electrode holder now. Just a standard one. Nothing fancy about it. So, little pro tip, guys. We have these rod stub buckets in our booth. What I love to do, and I like to keep a few rods in these. As you can see, we got a bit of a selection of rods in there. Don't want to dump them out, but yeah, a good selection. I like to keep some stubs in here because I love to use these stubs for tacking. A lot of people just want to toss them out when they get short, but instead of using a new rod for tacking, why not use an old rod? Use up more material, better usage of it, and stops you from just burning up, potentially ruining new rods as well. So I'm going to set this up here. I'm going to make sure it's not contacting anything because I am going to turn this on to turn on these welding machines. Right up here, I'll get you guys in close. If you haven't used one of these ones before, we'll take a look. So kind of hard to see, a little dark in here, but we have a pretty simple system. So we have our main amperage. We have a crisp or a soft start. I always keep it on crisp. We got to be on local input because remote is more for foot pedals for TIG. Arc force, we are working with 7018, so we're going to run 40% arc force, only 40. And hot start, I keep it about 5. That just helps you start the rod. Just a little bit extra kick at the beginning. Obviously, we have our positive and negative terminals. So we're running electrode positive or direct current electrode positive, so DCEP, which is also known as DCRP, reverse polarity. Yeah, so we got DCSP, DCRP, DCEN, DCEP, few different terms there. Electrode negative is the straight polarity. So right here, sorry, right there is the power switch. So we're gonna flick that sucker on. I've got this rod sitting at about 120 amps, which is fine for what I'm gonna do. I'm gonna take you guys into the booth. Just gonna grab a stool so I can set this up. And we're gonna tack up that piece. Firstly, before I do that though, I need to get a helmet, so I'll be right back. Just gonna grab some rods, and then we are good to go. All right, we can't forget welding gloves. One thing, guys, is we're gonna be running a 1/8 7018 today. That's gonna run about 120 amps. There are different sizes of 7018. In the rod oven, I keep numerous different sizes. So I've got 3/32, so that's a 32nd of an inch smaller than the 1/8. That's gonna run at about 85 amps. So definitely a big amperage change. But we also have some bigger ones, 532, a 32nd bigger than 1/8. That's gonna run about 150, 165. So a bit of a range there. So depending on the size of the job you're doing, the thickness of the material you're working with, you can actually step your rod size up. If you really want to go a bit bigger, how about 3/16 of an inch? So this rod's about 14 inches long, definitely much bigger than your standard 1/8. So 1/8 versus 3/16. So you can see there's a bit of a size difference there. But we're going to work with a 1/8 today because that's going to work best with the material that we have. So I was talking about tacking, guys. What I'm going to do is I'm going to tack these pieces up. And all I do is I put a small little weld on the end of my T-joint. So I'm going to stack these pieces up right here. I'm going to take this, I'm going to place it in the middle of right here, get it where I like it, and I'm just going to put a little button of weld right on the end of that T-joint. So I'll do that, and then we'll take a look at it. Then I'm going to straighten out the other end, line it up, and then get that welded down as well, or tacked down as well. Awesome. So we've got that where I like it. We'll tack this end down. Put that there. So all those tack welds are, guys, just little welds. I don't go into the weld joint at all, but these help secure those two pieces together. So we're not trying to hold it and weld it at the same time. So what we're going to do is we're going to pop in here into the weld joint. We're going to come in at a 45-degree angle, and we're going to put one nice pass all the way across here. We'll clean it up, and then we'll look at that afterwards. So for this, I'm going to switch to a new welding rod for the full length. Turn my amps down a little bit. I'm a little bit warm. Everything else is really nice where I want it. So with this, I'm going to come in at a 45-degree angle. I get myself set up so I can work across the joint nicely. 45 degrees, a little bit of a drag angle. Kind of like I said, hold it like a pencil. And for me, that would look kind of like this. So you're probably gonna see my rod look something like this while I'm welding. So that's gonna be kind of the angle I'm using. So probably not gonna see anything, but we'll come back as soon as this is done welding, and we'll clean it up, buff it up, and then we'll start stacking passes on here to show you guys how this all works. So here, guys, I'm just keeping it nice and slow, letting it fill in. Make sure I don't have undercut, looking for a nice, smooth weld when we're all done here. So I want you to be aware that stick welding is a hot process. You're putting a lot of heat into the steel. So that there, I burnt up the majority of a rod. I've got about 4 inches left. I'm gonna put it in that rod bucket. I'm gonna chip this off and cool it down, and we're gonna control the heat after every pass. This is just to help us not overheat the base metal and give ourselves a bunch of trouble by working with some super hot material and having it all wash out on us. So in here, we got the ability to control a lot of the variables. So why not use that opportunity? So you guys got headphones? Maybe just mute for a second. All right, so with this, guys, hard to see, but there's I wouldn't say it's the smoothest weld I've ever done, but it's definitely not a bad stringer. But the main thing I'm concerned about is how that profile looks. It's hard to see with these cameras, but this weld has a good profile. It's got that 45 the whole way down. And that's what we're looking for. So what I'm gonna do is I'm gonna cool this down. I'm gonna buff it up, and I'm gonna come back. We're gonna throw another pass on it. And I'll kind of show you how I build up for my final pass on the 3-pass fillet weld. All right, so we cleaned it up a little bit, a little easier to see. It's not the smoothest I've ever done, but definitely not terrible. So we're gonna throw a second pass on there. So we're gonna use a new rod. And we're just gonna make sure I can run side to side, no issue. And then we're just gonna weld. So we're gonna lay this in here now. All right, so a good pass on there. A little bit wider than I wanted with the amperage I'm running. It's a little hotter than I expected, but it's just one of those things we have to deal with. So when things start off, like this started off a little wider than I wanted, but to avoid a huge visual giveaway, I maintained that puddle width the whole way across, even though it wasn't ideal and not what I wanted. I'd rather have it be a little wide consistently than have be a little wide at the start and then a big jog in and then, you know, a tighter, basically stringer to the last one. You don't want any big visual clues or defects on here. Something that the eye is going to gravitate to right away. You want to try and avoid that. So what I did here is I just continued on with that puddle that was a little wider than I wanted. I'm going to make up for it on the last pass by putting in a little heavier last pass than I did second pass. That should pretty much cover up any of those little mistakes that I made along the way. So right here, haven't chipped it yet, but slag is all ready to come off here. Decent-ish looking. The slag is usually a really good indicator of what's underneath. If the slag looks consistent, chances are the weld is underneath. So we're going to chip this off. So pretty much just had to scratch that off. It all came off nice and easy. Looking at a pretty consistent pass there. So what we're gonna do is we're gonna cool this down and we're gonna lay one nice big top pass in there. Then we'll break this weld down and talk about it a bit. All right, so folks, with this one, you can see that weld right there. Hopefully light reveals it a little better. I pointed right at the toe of the bottom toe of that first weld I did. And so, like I said with the last pass, we're gonna point at this top toe of this weld. So it'll be the upper side right here. We're gonna put it right at the joint of where that weld meets the plate. We're gonna run that rod down through here, hopefully get a nice, smooth, consistent weld. That will wrap that up. One thing you may find is if you are coming in at a 45 degree and it is a little hot, it may create that undercut. So you may actually have to drop your angle a bit and use the arc force of the rod to push more steel into the back wall of the plate. That's gonna heat up the back plate more, but it's gonna keep more material against it and hopefully avoid any situation where we get undercut. Also a consistent travel speed where we're filling nice and evenly, not skipping along. That's going to give you undercut because the arc will cut steel away and not have a chance to fill it in before we move out of that space. So that steel will solidify, leaving undercut. So we're going to try for a nice, consistent travel speed the whole way, no undercut. All right, once again, I always check I can run the joint. I just make sure I'm not sticking on anything. There's nothing catching on the table. And I use the table as a support. I run my hand across the table right there. So I encourage you guys to do that as well. So what we're gonna do is gonna slide this forward a little bit and let's get this weld going. So used a fair amount of rod on that one. I got about 4 inches left again. I always save these for tacking and, you know, shorter things like stringer padding on plates. Definitely put some heat in there. Ran a nice sized bead, fairly consistent the whole way. We're going to take a look at it once I chip it off here. So good indicator that you got a smooth weld is how that slag removed. This stuff here pretty much fell off. There's a little bit of an inconsistency in the travel speed there. You can see a couple tiny waves, but nothing major. And the big thing that we've got here that I like is consistency on our weld bead profile. So we have this bottom leg nice and even, top leg is nice and even, size is uniform, and it's on that 45-degree angle. So I'm going to buff this, I'm going to cool it, I'm going to buff it, and we're going to take a quick look for undercut, and probably get you guys out of here for the day. All right, folks. So as well turned out fairly nice. Still pretty warm, but I will put gloves on to handle it just because it is pretty warm. But what we have here is a fairly consistent weld. There is, let's see if I can find any. There's no visible undercut whatsoever on that top edge, and that's a good thing. So I achieved that by doing a couple different things. What I did was I held my rod angle a little lower below the 45, probably more of a 60 degree from vertical. So I was probably running a 40-degree angle, maybe even a little less. I'd have to go back and look at the video. But what that's doing is pushing that material up against the back wall, right up in here. And that's holding it there long enough, that slower travel speed's holding it there long enough to make sure that it gets to solidify. Nice consistent bead here, looks good. Blending is pretty good. There you can see there's a little bit of a valley between the two stringers. Nothing terrible. I was mainly watching the top edge. What I do is I kind of watch the top edge of the puddle and then that little back of the C shape and just make sure it's all consistent. A lot of nice smooth C shapes here, smooth ripples. We don't want those rough, jagged, quick movements. That's going to give you those V shapes when we move our rod quick. So the C shape, definitely achieve that there. Looking pretty good. Hard to see on the camera. You guys come in, it'll look better. I might even take a picture and just pop it into the lesson here, or just throw it in the material for the class so you guys can see it. But overall went really well. 45-degree angle like we wanted. That's 3 passes with 1/8 rod at about 120 amps. Biggest thing with that is I always pre-run my my joint. Just make sure I can move from one end to the next without any hiccups or inconsistencies. And then once I do that, it's basically just down to travel speed. Get that rod lit, get it in there, and just focus on nice controlled movements. It's going to help you guys be successful. I do encourage leaning against the table, resting a hand, using a vice grip to create a rest, whatever it takes for you guys to do this. Never, ever, ever will you see a welder just stand in the middle of space, not touching anything, and weld whatever. Well, I won't say never, ever. It does happen, but I like to think of it as a football type of deal. So you're on the, you're out on the line. Everyone's lining up. They get down low. They get wide. Hand down for stability, and it's a low stable object. So they got 3 points of contact when they're doing that. I encourage as many points of contact as you can get with the table, a bench, something solid to work on, because that basically eliminates a lot of movement from our upper body. We wobble, we move around, but if we've got our elbow on something or our forearm on something and we're nice and stable, that's going to prevent a lot of movement, or a lot of unwanted movement anyways. We still have to be able to travel the weld joint back and forth, but you want to be able to do that in a way where you're not choppy movements. You want that nice, consistent travel speed the whole way across the joint. That's it for today, guys. I just wanted to talk about this. I'll put a picture in there in the thing, because the picture definitely will look nicer than this camera shows. So yeah, thanks for tuning in. Going to be getting a couple more things prepped and ready for you as far as quizzes, tests, some worksheet stuff. Then we're going to come back and kick some ass. So thanks for joining me. You guys are free to go. Have yourselves a great day. Stay healthy. If you have any questions, now's the time. Awesome. Well, no questions. Thank you much, folks. Have a good day. I'm out of here.